right, it's 2 minutes past the hour. We're gonna get started, and then if other people join a little bit late, that's okay. So, welcome everybody to another great green energy series. Today's green energy topic is about electric panel upgrades. We're going to talk about the different types of electrical panel upgrades and some of the new features and safety, both safety requirements and good to have safety features that have come about in the last between the last time your house may have gotten a new electric panel and today, and talk about some of those, and it's gonna be a great time. So this Green Energy Series is presented by Solar Oregon. Solar Oregon is a Oregon nonprofit that's been around for about 46 years. We do a lot of education, outreach, and community advocacy. If you check our Eventbrite page, we have a number of free events and webinars. There are many different scheduled instances of our How to Go Solar plus Storage webinar. That's kind of a intro 101 webinar to get new people who are new to the concept of solar to understand the lay of the land. We also have another repeating presentation, which is comparing solar quotes. So if you're further along in your solar journey and you've reached out to contractors and have gotten multiple quotes, that webinar is really useful. You can learn about how to compare those quotes, and then also in the Q&A section of those webinars, ask some of our experts on particular questions relevant specific to your quotes. We also do solar tours. Pictured on the right is a solar winery tour where we toured some agricultural lands where there's a marriage of agrivoltaics, which is solar plus agriculture, and oftentimes in these installations, the panels that are selected are what's called bifacial panels, so they let some light through, and turns out that some plants actually grow much better in not direct sunlight, and so they get less sunburnt, and so they grow better, and there's less evaporation, and so then there's less watering cost, and so the farm ends up having a revenue stream from the electricity generated and electricity sold, as well as some water savings and some higher quality plants. So it's a win-win-win-win across the board. We've gotten a chance to tour in the past some agrivoltaics projects. Recently, just earlier in January, there was a tour of a new multifamily high performance building in Tigard that has solar. And so whenever the community has a new fancy building, we typically reach out and are able to get a tour organized. And so keep an eye out for solar tours if you're interested in, in those unique buildings in our community. We also do solarized campaigns where we go through neighborhoods and try to enroll multiple houses in that neighborhood to go solar at the same time. It results in generally better quotes and lower cost per house because then the solar installer is able to purchase inverters and panels in bulk. And then also, there's less travel time and setup time to go from one house to another, solarizing those homes. And so all those different benefits results in net savings. And so we organize solarized campaigns. And then we also do many peer-to-peer educational events such as this Green Energy Series. So if you like any of the work that, I just described before, we're a member-based organization. You can visit Solar Oregon to become a member if you're not currently a member. Becoming a member gives you access to newsletters and access to these events. And in addition to that, we're also a fairly lean and mean organization, so we operate on quite small budgets. If you'd like to help with some of our expenses, feel free to visit this link to donate a small amount. For this webinar, we encourage you to use the Q&A feature to ask your questions. I'm sure that this topic will result in quite a few questions, so feel free to use that tool. So about me, my name is Edward Louie. During my Monday through Friday day job, I work at Pacific Northwest National Laboratory. It is one of 17 U.S. Department of Energy national labs. There, I'm a building energy efficiency research engineer. And so, uh, what I'm presenting on is tangentially related to my work, but not exactly. So, like when it comes to electrical work, I do not work that closely in electrical codes, and I'm certainly not an electrician. So, what I'm presenting is really just my best understanding of the Oregon electrical code and my understanding of residential electrical um, the residential electrical landscape. And you can find me on LinkedIn. I post quite frequently on my LinkedIn, and some of my outside of work projects includes building an off-grid zero energy tiny house on wheels. Um, Hopefully, when it's done, I would like to tow it around to different venues and show off some of the great features that I've thought about to put in this tiny house on wheels. So, to recap again, the views in this presentation don't reflect the position of Pacific Northwest National Laboratory, U.S. Department of Energy, or Solar Oregon. Um, at Solar Oregon, I'm a volunteer and a board member. So a best effort has been made to convey facts and information accurately. However, you're encouraged to do your own research and calculations before making investment decisions. So with that, we're going to dive into electrical panel upgrades. We're first going to talk about the different types of upgrades. There's the most extensive types of upgrade, which is a service entrance upgrade. So we're not just upgrading the equipment in the house, but also the wire going from the house to the electric utility pole and potentially even the electric utility transformer that's on the pole. Um, and then all the way to a much less extensive electrical upgrade, which is like adding a circuit or upgrading something on an existing circuit. And then we're going to talk about when you do these upgrades, maybe there's certain uh, things about that circuit or your house that don't meet current safety standards that would be triggered to when you do these upgrades to be required to also be upgraded. And then surprisingly, a number of features that are required in the standard version of the National Electric Code that when Oregon adopted that electric code, they decided, no, well, we don't want to actually burden Oregonians with that requirement when if they don't want to. And so Oregon made a number of requirements optional. And so we'll go through some of those changes. And but despite making it optional, we'll also kind of talk about, why would anybody, why would somebody be interested in the additional cost to install that feature in their home? So everything that, is a good idea or required in the 2023 electric code, there's reasons for it. So even if Oregon made it optional, there may be good reasons why you would want it. So with that, as I said, the most extensive upgrade a house can get in terms of electrical is a service entrance upgrade. So this upgrade typically does involve upgrading the circuit breaker panel also, but it also involves upgrading the wires from between the circuit breaker panel and the electric utility pole. So typically why this is done is because some older homes, when the homes had very few electric plug-in and electrical uses and needs, the electric utility, 100 years ago provided a much smaller wire because homes used a lot less electricity. And so if your home is still, very old and has that small wire, as you modernize the home, add more circuits, electrify your home, the small wire from 100 years ago might not be sufficient. And so that's why you may need to um, make an upgrade. But so then what is involved in this upgrade? It involves a coordination between the electric utility company and your electrician. So the graphic on the right shows the red or orange components are provided by your electric utility. In this case, this graphic was created by Portland General Electric, but if you're in Pacific Power territory, uh, the standard of practice is probably very similar. Um, Same thing if you're in a rural electric authority in Oregon. Um, and so those are the components that the electric utility would provide. And then all the dark colored components are components that your electrician would provide. And they may show up as a line item in your bid from an electrician. And so uh, when typically, when would you want to upgrade from a this service entrance equipment is if your existing equipment can only supply 100 amps or less. Um, a modern electrical service entrance for a single family home is 200 amps. And so, but what we've found at PNNL and other research organizations is that homes that don't have electric resistance heat, like if you're not using electric baseboard heat for heat or wall cadet heaters, or you don't have an electric furnace, those homes that don't use electric resistance heat, man, they really struggle to even come close to using 100 amps. So even though modern, if you were to do this upgrade, for sure they're going to upgrade you to 200 amps. If you have like let's say 125 amp or 150 amp service entrance capacity, the chance that you need to upgrade is quite small because, gosh, you're very unlikely to use over 100 amps. But one way to know for sure if your home's usage and usage patterns result in a 1 second or 1 minute peak usage of 100 amps or more is to have an electrician um, install an energy monitor in your existing electric circuit breaker panel. Um, and then that way you're able to get 1 minute data, and periodically in the year you check that data to see what is that 1 minute peak. And if you find that it's 60 amps, then it's 60 amps. But if it's a 100 amps and you have 100 amp service, but then you're thinking about buying an electric car that would then add another 50 amps to your requirements, well, then you do need an electric service entrance upgrade. So that's kind of the logic of maybe do some behind the meter energy usage research first. So I spoke about electric service entrance upgrades. So let's say you do that research and putting an energy monitor on each of these circuits, and you find that your current peak energy usage is only about like 35 amps. So, but you want to get that electric car or you want to get the induction stove, but your panel looks like the one in the middle and it's 100% full or like there's one slot left. So that's where the panel upgrade comes in. Um, it, it, so if you can buy panels that don't increase the capacity at the service entrance. So like if this panel in the middle is 125 amp service entrance, you can buy a circuit breaker panel that's also 125 amps with more circuit breaker capacity. And that's because again, like you may have a lot of circuit breakers in the panel, but you're not using electricity from each circuit breaker all at the same time. And so as long as the home usage pattern doesn't exceed the service entrance capacity, you're okay. Another thing is circuit breakers in the most basic form are meant to protect the wires from overload. So it's to prevent the wires insulation from melting and getting too hot. And so let's say you have a panel that you manage to find, which they don't actually make panels that are with 100 circuit breaker slots for 100 amp service entrance. Like there's the manufacturers have taken some assumptions on and have limited some of those parameters. But like for like 100 amp or 125 amp service panel, if you only have like 24 slots and you want one that has 30 slots, you can easily find one that has if that those few extra slots. Um, but like the circuit breaker at the very top, that's the one that protects the service entrance wire from, getting too hot and consuming too much current. And then, of course, then each branch circuit breaker protects the wire for that branch circuit. Um, Now, let's say, your panel is like you have one slot open, but the project you're doing for, requires two slots. So one of the things you could do is also label all your circuit breakers and, take a weekend and take the time to like flip one of them off, see what in your house turned off, and then just build a map of what's on each circuit breaker. And if you find that you may discover that, there's one circuit breaker or maybe two that's hardly powering anything that you ever use. And so in those cases, you may be able to hire an electrician to actually combine the barely used circuits to be powered by another circuit breaker adjacent to it. And then that will then free up some of the slot spaces so that you might just be able to gain like this number of slots you need to do your project. So that's the one solution if you only need one additional slot or two extra additional slots. Um, Now, also like the circuit breakers pictured here are fairly modern ones. But if you have a circuit breaker panel that's from the 1970s or 1980s, or maybe even the 1960s, and it's made by companies like Zinsco, Federal Pacific, or Pushmatic, these are panels with circuit breakers that are known to not trip even if you uh, pull too much electricity out of one circuit. So they're well known to actually result in the wire burning up or melting the insulation before tripping the circuit breaker. And so many electricians, if they see that you have one of these, they'll just automatically say that, hey, you need a panel upgrade. They won't touch it. So the easiest one is upgrade is if you have a um, fairly modern circuit breaker panel, so meaning that the circuit breakers are readily available and they're safe, and your panel has some additional slots, and then in which case, then an electrician can easily just supply you with the new circuit breaker needed to do your project. Um, Now, some things to think about is even if you have additional slots, you may want to think strategically because most homes don't have, like I said, they don't have 12 extra slots or, it's not a lot of extra slots. You may end up having like, you know, two or four or maybe five extra slots. Now, if your long-term electrical upgrade plan includes, like going from a gas stove to induction stove, and a gas dryer to a heat pump dryer, and a gas furnace to an electric heat pump. Now, that's quite a few upgrades that all require maybe some additional circuit breakers. And so um, at that point, you may have your long-term electric upgrade path would um, utilize too many circuit breakers than your panel has space for. So um, one of the things that has come into play is like bigger appliances that traditionally use a two pole or two slot 240-volt circuit breaker. There are now 120-volt shared circuit options for those appliances, and we'll get into them. Some of them are water heaters, some of them are even heat pumps. And so think strategically about you know those options and compare those options with actually like having an electrician pull a new circuit that's 240 volts and using those slots. You may want to, for example, reserve a slot for your gas stove to an induction stove or an electric vehicle charger where there is no kind of 120 volt option, rather than using up a slot for something where there is a 120 volt option. Um, Another thing about, creating more space is some panels do allow you to use tandem breakers, which are half breakers. So, like for example, in this picture here, these breakers use one slot and there's one flip per slot. Tandem breakers have two flips per slot and allow you to insert two wires, um, and that will save some space and allow you to open up the number of slots in your existing circuit breaker panel. Um, Now, not every panel allows you to use tandem breakers, and those that do let you use tandem breakers often like you're only allowed to use it in certain slots, and so you have to look carefully or have an electrician evaluate your panel to understand whether tandem breakers is even an option. Um, and then if you're adding new circuits, that's great. You have something new and fancy to enjoy, but don't also neglect the existing circuits. So, like, the existing circuit powering your bedroom uh, receptacles or wall outlets. If when you plug in your cell phone charger and it's like about to fall back out of the plug, um, that means that plug is really worn out and it's really a safety issue. And so, like, when it comes to electrical upgrades, don't just think about like, oh, well, I want this new fancy thing, um, and think about that upgrade, but also like the maintenance and replacement of worn items in the existing electrical system. So keep that in mind. So I was saying, in the previous slide that, there are appliances that, man, like in the past, no one would dream that, they could be on a shared circuit running on 120 volts, but technology's really moved ahead, and we now have, for example, 80-gallon water heaters that operate on 120 volts and can be plugged into a shared circuit. Um, so that's very impressive, and these things are very energy efficient also. Um, like there's an electrical code rule saying that if it's a fastened in place piece of equipment, which a water heater obviously is fastened in place, that if it's going to be on a branch circuit that's shared with other items, that fastened in place uh, appliance cannot use more than 50% of the amperage rating of that um, branch circuit. And these heat pump water heaters, as you see in the spec sheet, they use 440 watts. And if you do the math, it translates to 3.66 amps, which is way less than half of 15 amps. So they can definitely go on to shared circuits, and you still have enough electricity in that shared circuit to power your laptop, your cell phones, and maybe some overhead lights, etc., etc. Another kind of area that in a few years ago, people might not have dreamed that you could put on a shared circuit is a serious uh, piece of heating equipment for a home. Typically, like, window air conditioners have been around for decades and decades. But, the ones that for window air conditioning, they use enough energy that you may not be able to have anything else on it. But now, and then they don't produce heat in the wintertime. And now you'll see these become more available in 2025. They were launched and kind of announced and limited pilot testing in previous years, but I think 2025 these window heat pumps will become actually purchasable by the mass consumer market. And these things, the power requirement is on the coldest day when they're, at running at 100% of 100%, they use 12 amps, and 12 amps is 80% of a 15 amp branch circuit, which is the smallest um, amp rating in a typical home. And so the code requirement is that cord and plug equipment not fastened in place, they cannot use more than 80% of the branch circuit. So this one's right at that, limit. The reason why, they can't exceed 80% is because there's the idea, well, you might still have some LED lights. You still might, on that same circuit, have, your laptop computer, your cell phone, and, other things, that use a small amount of electricity. So you want to provide that little 20% um, for those additional things on this shared circuit. Um, but man, like think about it. Like, let's say like your home has, three branch circuits powering different parts of the home. You make sure that, you don't put two of these on the same circuit, because that won't work. But you put one on each branch circuit, you might be able to heat and cool your whole house, with three of these distributed throughout the home. And so then, instead of having to do like ductless heat pumps or a central heat pump, get three of these and you might be done. This is also really good for renters. If you're renting a home, you're not able to make, permanent changes. But, if your landlord has electric resistant baseboard and you're paying $300 or $400 electric bills, you might get two or three of these and power your whole, rental unit, rental house, and, save a lot of money on your electricity. And then when you move out of that rental, then you can take them with you and put them in the next one. So some good ideas are possible because of new technology. Here's another kind of important thing. It's important, but believe it or not, it's not in the National Electric Code as a requirement. It's in the National Electric Code as a recommendation, and then Oregon version of adoption of the electric code doesn't make any make changes in terms of recommendation or requirement. It's just buried in the electric code as a recommendation, and that's voltage drop. Um, so uh, the reason why this is not a what's it called, a requirement, is because if you plug in, let's say like an electric resistant space heater, um, and you get voltage drop from that load, then instead of, putting out, let's say like, the space heater is rated for, um, let's say 1500 watts. If it gets less voltage, then it just won't produce 1500 watts. It might produce only like 1200 watts. Um, but increasingly, we have more sensitive electronics. So, like for example, that very energy efficient window heat pump in the previous slide, or that very efficient heat pump water heater in the slide before that, they have circuit boards and they expect you to, have a certain voltage. And so if they don't get a certain voltage, they may not operate as well, and they might have problems, because they run on a lot more electronics. And so, and voltage drop is a function of, some bad connections between, the different daisy chains in a branch circuit. It's also a function of very long branch circuit wiring. So, like, let's say, you have 20 or 30 items daisy chained together. Well, if you add up the length of the wire for that branch circuit, it'd be very long. And so the outlets near the end of that branch circuit could have pretty significant voltage drops, and an electrician with, proper testing equipment can measure the amount of voltage drop when you plug something in and put a load on that receptacle. So the recommendation by the National Electric Code is that the voltage drop when it should not exceed 5%. And I've seen homes where the voltage drop is like 17%. So it's if you plug in something that uses more than, a few watts, like a laptop computer or a cell phone, if you plug in something like a refrigerator on that circuit, on that plug that has a 17% voltage drop, you might run into significant problems. And so, and things are getting more expensive, with refrigerators having more technology and features. You really don't want these expensive plug-in appliances to result in a shorter life or problem because of, not proper voltage being supplied. So that's something to consider, having an electrician do this type of testing and, fix the cause of the voltage drop if it doesn't meet this 5% rule or recommendation. Another kind of thing about the electrical system in your home is, like I said, way back in the day, electrical safety was really about protecting the wire to prevent, if you plug in too many things and turn them all on at the same time, that, it doesn't melt the wire inside the wall and cause a fire. But increasingly, electrical is not safety is not just about protecting that wire and preventing that wire from melting inside the wall, but also protecting the humans that use the electrical devices. And uh, one of the major improvements is, ground fault circuit interrupters. So these things measure the amount of electricity coming out of a device, and then it monitors how much of it goes back, um, and it measures the neutral, which is where the electricity goes back. And if the two don't equal each other, then gosh, some of it might have disappeared. And where did it disappear to? It might have disappeared to electrocute the human that's using the appliance. And so if they don't equal, then they'll trip. And the difference is a very, very small amount of electricity, something like 5 to 7 milliwatts of electricity. So they're very sensitive. And uh, the code has gradually increased the scope of the locations where GFCI is required. Um, but and they are somewhat affordable. Ground fault circuit interrupters are like about 20 some dollars per receptacle if you go to like Home Depot, Lowe's and buy a GFCI. But they add up. If you're going to spend 20 some dollars protecting each branch circuit, that's adds up to, if you got 10 circuits you're protecting, that's 200 some dollars. Um, and so Oregon did not adopt a revised language in 23 that would require GFCI for range receptacles, refrigerator receptacles, disposals, and microwaves. The idea is that, well, the chance, for example, of you having a ground fault issue for a electric receptacle is pretty small. And there's the chance of you unplugging your fridge or pulling your fridge out to unplug it and then plug something in, and then you using that appliance and then having a ground fault, that's even smaller. So, they're just trying to evaluate the cost to consumers to require this versus the additional benefits. And, we'll see that theme play out in other situations where Oregon did not adopt a requirement that is in the standard version of the National Electric Code. It's mostly kind of a balance of, cost to consumers when we require it versus making it optional or not required. Kind of another update is in this picture, which is uh, receptacles within 6 feet of the outside edge of a bathtub or shower should not be installed within the bathroom. And then if it's within 6 feet, it needs to be GFCI. And so this picture here, obviously, this receptacle it is not within the bathroom, so it meets that requirement, but it is within 6 feet of that shower stall. So in this picture, is being changed out to GFCI. And you can kind of imagine maybe where this requirement came from. Somebody, uh, really wanting to use a electrical device inside the shower while it's, still warm. Maybe on a winter day, you step out of the shower, it's very cold. So then maybe somebody wants to use a hair dryer while in the shower. But it's a wet location, so somebody got shocked, and so somebody looked into that incident and said, well, a GFCI would have protected that person and only cost $25, so let's make it a requirement. So another location that is being pushed towards having GFCI protection is the outdoor unit of your air conditioner or heat pump. But when that first idea came into play, not even in 23 electric code cycle, but the 2020 electric cycle, I think, the experiments found out that the startup of air conditioners and heat pumps creates some transient voltage electrical behaviors that results in tripping the GFCI. And so these nuisance trips, and the electric industry has not yet produced a GFCI that can distinguish a real ground fault versus these transient electrical um, uh, uh, signatures that come out of the outdoor unit. And so This requirement has been continuously pushed forward. So like the effective date is now September 1st to 26th, and the hope is that, well, some research and development in the companies that make these electrical safety devices, that they'll be successful in making a product and putting it to market by that date. But if not, then they'll probably continue to push it forward. Um, and this is to protect the HVAC technician if there's a ground faults from getting electrocuted. So it's a good idea if they don't cause nuisance trips. So Oregon, in their adoption of 23 electric code, um, didn't want to put a specific date because, as I said, the industry is really unsure on what the date is. So their language for outdoor GFCI protection is that out general purpose receptacles need to have GFCI protection. Um, but this one is not general purpose, it's specific to the outdoor unit, so therefore it doesn't qualify. So that's the Oregon solution to trying to have a date, but then that date be a constant moving target. Another kind of place that, we want to think about GFCI protection is electric vehicle charging equipment. So under this requirement, if you plug in a level one electric vehicle charger to a receptacle that can also plug in holiday lights and your lawn landscaping equipment, that's a general purpose receptacle, so it would need to be GFCI protected. um, but for well, what about level two electric vehicle charging equipment? Well, if it's above 50 amps for a branch circuit, it does not need to be. Um, and the question then is like, okay, well, why would a level one require it, but a level two that's over 50 amps not require GFCI? Well, technically, like even a level one wouldn't need a GFCI for the electric vehicle charging stuff, but it's to protect, like, if you were using a weed whacker or using holiday lights, which have less protection. That's why that general purpose receptacle needs GFCI protection. The electric vehicle charging equipment actually have quite a few safety protections built in. Like there's a switch so that when you press that switch to unlock and pull out the electric charger from the ports on your car, that button will actually automatically shut off electricity flowing through those cables. And so as soon as you touch it and then like press the button, there's no electricity flowing through. And that's true for level one and level two. They have built-in fault protections in that kind of brick shown in the middle picture. So we don't really need to worry about electric vehicle charging too much, but the code is there for general purpose. And so the question is then like, okay, if we were going to put a general purpose socket for this electric vehicle and it's level two, because like that socket there shown in the right hand picture, you can plug in not just your electric vehicle, even though it's a strange looking plug. You can plug in not only electric vehicle, but you can plug in an RV, you can plug in other things. So it could be argued as general purpose, right? But the thing is that the fastest level two chargers use 48 amps, and being a continuous load, you're charging your car for hours. Um, that wire, the code requires that wire to be 120 size for 125% of 48 amps. So then that's 60 amps. 60 amp circuit breaker is obviously larger than 50 amps, and so it doesn't actually, this requirement doesn't apply to a 60 amp circuit. Um, so that's where that GFCI is not required. Arc fault circuit interrupters. This idea is okay. Well, if you hang a picture in your house and then you put in that screw or nail to hang the picture and it pierces through a electric wire inside the wall, you might get arcing, and that arcing can then burn your house down. And so arc fault circuit interrupters are programmed to detect a arcing electrical situation and shut that branch circuit off to protect your house. And um, now, Oregon did not make this a requirement. They're saying that if you're extending a circuit or replacing a electric circuit breaker panel, you're not required to upgrade your house to meet all the arc fault requirements. Now, if you're building new construction, that you don't get exception one or two. You have to put in arc fault circuit interrupters. Um, but the idea behind this is that these circuit breakers are kind of expensive. Like here's one for $62, and if you put in enough to actually meet all the requirements where you need to install one, you might be talking about 67 or even $800 in circuit breakers. So that's could be very cost prohibitive to a homeowner interested in just installing a circuit breaker for something and not expecting to trigger a whole host of other unexpected costs. So this is the unexpected cost that, the Oregon um, amendment to the NEC tries to prevent. And also the other argument would be like, well, my house is 65 years old and it hasn't burned down yet. Why do I suddenly need to have these breakers that cost me $600 to $700? So that it's somewhat of a logical argument. Surge protectors and barriers. So the barriers is those yellow things protecting the connector that's always live. Um, and so the standard version of the electric code says that you need to have a surge protector and you need to have barriers. But Oregon again looked at the cost versus benefits and decided not to adopt these line items in the 23 electric code. They're still a good to have item if you can afford them. In fact, like if you're to get a panel upgrade, almost all the panels you can buy today come with those barriers because, well, many states did adopt this, so you don't get an exception. And the panel manufacturers don't make panels just for Oregon; they make them for all 50 states, and so whoever has the strictest codes, defines the standards. But the idea is, well, only qualified people poke around these inside these panels. And so if you're a qualified person, then you're unlikely to make the mistake of touching live parts. And so maybe we shouldn't require it. There's a provision for convenience outlets for HVAC equipment. So the idea is that, you need to have a outlet for your HVAC technician to work on your equipment. Oregon said, well, most HVAC technicians own a extension cord, and so therefore, if you have a outlet in the same level as your equipment within 75 feet, you don't need to provide a convenience receptacle. And so, yeah, that's true. I mean, if you're in the HVAC business, you should have an extension cord. Power monitoring equipment. So this is the energy monitoring stuff I was talking about. It's not required in either the NEC code, and it's also not required in the Oregon code. But it's a nice to have feature. Again, like, it could actually save you money in the long run if you're looking to upgrade your deciding whether you need to do a surface entrance upgrade or whether you just need to upgrade your circuit breaker panel. Um, and so using this, you can look at the 1 minute peak energy use to see whether you have enough capacity based on the usage behavior of your house currently to just do the panel upgrade and not need the surface entrance upgrade. So, that you could be money ahead having this. Ready bit. So, location of the electric panel. Why would anybody have an electric panel on top of a toilet? I don't understand it, but I mean, homes that get remodeled and remodeled and remodeled, and maybe the panel wasn't in a bathroom, but then after a few remodels, it ended up being in a bathroom. And so, Oregon has some updated language to say that, well, if the panel was installed prior to 1993, you can have it near the bathroom still. And then if the installation was made prior to 1978, then you can have your panel remain inside a cupboard as long as your cupboard is 30 inches wide. That's a minimum working space for an electrician. Then it's acceptable. And so, these are, good to haves because, moving a panel just because you are interested in adding a circuit is very expensive. And so, if you can, meet these provisions and not need to move a panel, that could save a homeowner a lot of money. Now this provision about water pipe using as a ground. So in the past, water pipes were made out of metal. Obviously, modern pipes are mostly plastic, or increasingly, plastic is the choice for water pipes. And so back in the day when, there was no plastic pipes, then, using a water pipe as a ground is not the worst idea in the world. But now with more and more pipes being plastic, um, and if you have a water pipe problem, the chance that, your plumber is going to switch to using a plastic pipe is nearly 100%. So therefore, the Oregon Electric Code um, is saying that if your existing electric system is using a water pipe as ground, you need to first verify that it is actually grounded, not just like connected to the metal portion of the water pipe, but then subsequently, when it goes in dirt outside, it's plastic. So you need to verify it's a ground. But in addition to that, you need to actually put in a real grounding electrode. Um, and that's because, well, a year or two down the road, maybe that metal pipe that's in the dirt outside in the yard will burst, and then you hire a plumber to change it to plastic, and now suddenly, your system is not grounded. So that's why, when you do an upgrade, they want the ground to also be grounded to a grounding electrode. Now, Oregon is also one of the unique states in that we have a very unique provision for knob and tube wiring. Commonly you hear that knob and tube wiring must be replaced, but Oregon is saying, well, if you have an electrician, look at the wiring to make sure it's safe, and you follow these six provisions, um, and then technically the knob and tube wiring is actually not dangerous if you follow provisions 1 through 6. And so then you can actually drill and fill a wall with insulation that has knob and tube wiring inside the stud cavity. And you can insulate your attic with knob and tube wiring in the attic, provided that an electrician has looked at and made sure that these following conditions are met. So therefore, you can do this in Oregon. In many other states, you cannot. Um, Now your insulation contractor might still have some, misgivings about, performing the insulation when there's a knob and tube wiring in the attic. Um, but typically that misgiving comes from, people not knowing that they can hire an electrician to look at the wires and then having them sign off and then giving that, you know, uh, what's it called? Safety check over to the insulation contractor. If the insulation contractor doesn't have any knowledge, an electrician having looked at the knob and tube wiring, of course they're going to be kind of, uneasy about the knob and tube wiring. But, if they get a letter from you, from the electrician, then, they might feel better about applying insulation to knob and tube wiring. So that's kind of covering all the kind of the landscape of the electric panel upgrades, and then the must-haves, and then many, as you know, as you saw, many of them are in the Oregon adoption of the National Electric Code changed to good to haves, not necessarily a must-have. And that's really a decision to not trigger unnecessary expenses that a customer didn't expect. Um, and so so that's good for Oregonians. But these electric safety requirements that are recommended in the unamended version of the National Electric Code, they were put in there for a good reason. They do improve the safety of your home and the safety of the occupants in the home. So, if you can afford some of these upgrades, then you should think about doing them. But they're certainly not a requirement. So that's that. And I want to tee up the next Green Energy series. Mark your calendars for March 1st. It's going to be about dual fuel HVAC systems. So dual fuel HVAC systems are they use both gas and electricity. So the idea is like on a mild day, the system would use electricity, but then on a very cold day, maybe it would use gas. And then also there we'll talk about some of the smart controls that could be implemented so that, like, if you're on time of use electricity or peak time electric programs, that, during the energy peaks on the electric grid, then it would switch over to using gas. Um, so we'll get into all that March 1st. And if you're interested in this topic, it's on Eventbrite, so you can sign up now and not miss it. So with that, I will look at question and answers to see if there are any questions and answers stuff. Let's go to Q&A. Chat seems disabled. Oh, okay. Let's see if I can enable it. Uh, Okay, I'm not sure. But there's a question about Zinsco panels. Um, I'm not familiar that Zinsco panels are still being advertised. I do know that there's a some companies making compatible circuit breakers for Zinsco panels. Um, and those compatible circuit breakers for Zinsco panels are not faulty like the old ones, so they do work, they do trip. Um, you do need to look very carefully if you have a Zinsco panel and you want to replace the old breakers with new compatible with Zinsco panel circuit breakers, to check the bus bar in the back to see whether it's been damaged from, you know, overcurrent from the old circuit breakers. So the bus bar on Zinsco panels are not very good either. So it's not just the circuit breakers aren't very good, it's the bus bar is not very good also. So you definitely need to check the bus bar also. Um, but you may find few electricians that are willing to take that risk. Um, they may just recommend that if you have a Zinsco panel that you need to re replace the whole panel. It doesn't actually cost that much more than just pulling all the circuit breakers out from a Zinsco panel and replacing them with more modern Zinsco compatible breakers. Let's see. Uh, just, okay, well, we the Q&A does work, it seems. So if you have more questions, put them there and not the chat. Um, I'm struggling to see if how to turn on the chat. But I'm not seeing. Oh, there's another one. Any recommendations for battery generator, backup, or solar when considering a panel upgrade? So there's no requirement that you put in a breaker for a battery generator or solar when you're doing a panel upgrade. But it's one of those good to haves. If you currently don't have solar or a battery or generator interconnect, that may be one of those upgrades that you want to do. And if you don't do them now, it's good to reserve the slots in the circuit breaker for the breaker for the solar input for the inverter, and then also um, any sort of breaker for a generator. The breakers for a generator need to be positioned in a very special location. It needs to be at the very near that it's like the first slot to the main breaker of the house. And the reason is because um, when you have a generator, there needs to be an interlock with the main breaker so that you're not backfeeding the grid while running your generator at the same time. So that's why the circuit breaker for a generator needs to be a very specific location. And if you want that option, you want to install that, when you're upgrading your panel, because if you didn't tell the electrician about that, they're going to insert breakers without having that consideration. And then once your panel's full of circuit breakers and you decide you can't put that circuit breaker for the generator at the very bottom, far away from the main breakers. So, very important to think about that if you want that feature in your house. Other questions? This is good. Well, I'm not seeing other questions. So with that, then we'll conclude this green energy series, and I look forward to seeing some of you guys on the next green energy series. And have a great rest of your Saturday. Um, and with that, we'll conclude.